Good morning, hello. Um, uh, we are continuing to work on our random drop game. Random being more of like physics random rather than like just randomly giving it a velocity. And I think today we can go on and do get some things on the screen. So right now, if we run, we have a nice blank screen, but we're able to see the choices that we have here. So what I'm thinking about doing now is getting Rapier 2D involved and getting these choices inside of the game where we can see the colors selected. I don't know about the names. I don't know how I want to like show those off. I don't know if I necessarily need to either. Maybe we can have like a key on the right hand side. I don't know. Maybe for version 1 we won't have anything like that. In order to do that, let's actually grab Rapier 2D. Where's my browser? Okay, so it is spelled that way. I want to say there was a better way of pulling it in from last time. Forget what that was. Right, this was it. Bringing it in so we can get SIMD stable. And we're actually going to lock it to a version. Okay, so if we have that, we also have GGEZ, so we're good to go there. I believe then we want to create meshes at the end, but that shouldn't be too terribly hard. We're going to need to have like keep size and other information probably separately. I think we're going to do the same thing we did during the exploration. We'll have like hash maps for each of the other things that we care about, and then that will be essentially we'll have a UID, which will kind of just be the index of these. I suppose it could just be a vector too, and that's what the index is. Although if it's a use size and not a U64, it'll be easier if we just use hash map because then we can use that. I don't remember. I think it's a U128, which is not necessarily helpful. All right, so let's go ahead and remember what we need for this physics. There was sort of like a lot of things in here, and I kind of wonder whether or not I actually want that all in main state. If we actually come down here to rigid body, see we need all of these things for the pipeline step. So how would I potentially handle this? I might want to create a struct specifically for our physics. Maybe that would be best. So we can have like a physics struct, and that's going to store all of these things. So that way we don't have to have like main state hold those things for us. So I'm going to go ahead and create that here. Don't think you need to be public. We're just kind of a mod physics. And so inside of here, this is where we're going to be storing all of these things. Like gravity and integration parameters and whatever these are. And we can see, okay, so right, because there's tons of these sort of like choices that we have to make as we're building them out. And then we have this loop for the pipeline steps. That's going to be us stepping through and creating that. So I'm going to put this to the side. Right now, what I care about is eventually I do want to care about these, I think. But right now, I guess I won't. Okay, so we have a pipeline. And that's going to be our physics pipeline. Okay, we're going to import physics, hub function new. We're setting this up. We're going to bring in the config, which is a reference to the config. And doesn't look like we need to return a result. So we can just go ahead and return a self. So in this case, a self with a pipeline is a physics pipeline new. The nice thing about config is that for any of like the actual parameters we want to add in here, like for example, this gravity that we see that we need here, we can throw this into our, not that. We can throw this into our config. So config JSON, we can have gravity. This could just be the Y value of this. Yeah, that makes sense. Gravity would only affect Y, so we would want this to be something like we can keep with like the let's do like 25. Okay, so with gravity of that, then we want to come back into no trailing comma on JSON files. Okay, so that should pull in here for us. We should now be able to actually create our gravity. So gravity, you're going to be a vector2, which is this Rapier 2D vector and algebra vector 2. Now, will you let me do this nicely? Or Rust Analyzer, are you going to yell at me like crazy and I'll have to like create some helper in order to like not have red everywhere? All right, so gravity, you're going to be a vector 2 new, and then it's going to yell at me. So in this case, it's going to be 0.0 for the X, and for the Y, we're going to have a config.gravity. And as we can see here, it's expecting these 4 arguments. So I think what I need to do is have a helper. Just call like an NA vector 2. And so we're just going to basically re-export a function that like just returns an algebra vector 2. So that's going to be, I mean, this could even just be a vector 2 that like returns a vector 2 when we want it to be. Actually, that might be interesting. We can store, so I wonder if I should have this something like a pub struct vector 2, where we have the x is an f32, y is an f32. We can import this vector 2. So this is all great. And I guess in here, I don't necessarily want to store the, oh, internally we can store this as a vector 2. So then this would be just data would be a, shouldn't call it a vector 2. Obviously this should be a, let's actually bring in vector 2 separately instead of re-exporting it. So in this case, I can rename you to just vector 2. That's all we really care about here. For this mod, that properly gets updated. Our data, however, here is going to be a vector 2 from n algebra. That's a really bad idea. We need you to use, oh, I was kind of hoping it would, no, don't use a GGZ one. That's silly. This is going to be a n algebra vector 2, f32 is inside. That's all I really care about. So then in here, we take in an x and a y, and we're going to return a self data algebra. Oh, right. And we have to do this in a way that Rust Analyzer doesn't just yell at us about this. So we have a vector 2. We have to have this be mutable equals an algebra vector 2 default. We have to tell you that you need to be a algebra. Actually, I don't know if I need to tell it, because it should figure this out. So if we just do vector 2 here, it knows that this is going to be f32s inside. And then down here to actually override the arms, I have a vector 2 x equals x. And then we can maybe have like, we need a we need some method to like get out what that vector is. So we can maybe have like a function to an algebra. It's not an algebra. Maybe get an algebra. Is that really what I want? I don't know if that's really what I want here for that, but I'm not sure. And we're going to return a reference to an N algebra vector 2 F32. This is just going to return a reference to self.data. All right, perfect. So head back to physics now. And so this gravity is actually going to be our vector 2. So a little bit of a facade pattern here. So we're going to have a vector 2, which is going to be ours. So vector 2 new, we give that what we want, and now we'll be able to extract out the N algebra vector 2 from that when we need to. Okay, what's next? Integration parameters. You are integration parameters. Okay, so we'll just have default for right now. I think we can change this around later if we want to. For any one of these, we can basically extract it out into a different variable and then just update it. Okay, then we have our broad phase, the narrow phase. So, I can just make these faster. By doing this. All right, so don't need you. Okay, so you're going to be at the end. Then for broad phase, this is a broad phase. For narrow phase, it's a, well, shockingly, it's a narrow phase. For bodies, this is a rigid body set. For colliders, it's a collider set. Joints, it's a joint set. And CCD solver is a, well, CCD solver. Okay, so that makes you happy there. Then we can continue building these out. So broad phase, these are all basically just like the defaults for it. So phase, new. All of them are going to be news. Okay, so we have a new here. Meaning that we can now just like set this up and get this going inside of our main library. So we can have our physics engine in here. And this is going to be our physics. physics new, and we pass it in a reference to the config. Oh, and you need to implement debug. Hopefully we can. No, we cannot. Okay. How do I tell it to ignore debug for this specific one? Either that, or I just don't worry about it, and I don't do that. That works too. Bar opt moved here because it's moved here. Yeah, okay, so we have to do this in a variable up here. All right, so now we have our physics. We have those choices. We'll probably want to like initialize next. Something like that, where we like maybe, oh, we could probably have it load all of the want to load everything. And we might want to do that like on the first frame too. Kind of like the idea though of us in main, we can, after we've created the new main state, we could run some kind of like initialize function and get everything in there. We have all the choices. We have the config, and we have the physics. At this point in time, we just need to load things in. So that shouldn't be too terribly hard. Yeah, let's have like maybe like setup. And then here I think we need the context because we need to know what the drawable size is. No, we don't, because we have the config, and the config can tell us what the drawable size is. So this might just work. I don't know if we need a result or not. So let's say I want to loop through and create each of these items in the choices. So that might be calling another function here. A private function maybe, or like insert, or maybe like generate sources, create choice balls, self send here, we call that. Okay, so what does this mean? We want to loop through our choices. So for choice in self dot choices, let's make sure we're not owning it. We should be able to, we can just debug this choice just to make sure we're seeing what we think that we're seeing. 2 errors. Oh, right. Main state, no longer do that. Oscar Ellen, hello. Okay, so let's go ahead and restart Rust Analyzer. After we create the main state, we need to do a main state dot setup, I think is what we called it. Then I think we can run this. How are you doing today, Oscar Ellen? Doing fine. Awesome. That's great to hear. Rust is coming along. We're just setting up a 2D physics library called Rapier 2D into the project. Okay, so here's our choice. We see, okay, we get the name of it and we get the color. So perfect. And it's an actual GGEZ color. So that is excellent. So back to our main library here. What we want to do is insert an item into our physics engine. To do this, we have to create a new rigid body, and then we can just sort of associate things with it based upon what we want to see. Now, how do I want to sort of handle that? I think this needs to be handled inside of physics here, since this is kind of being a facade pattern for our 2D physics library. We can have like a pub function. Guess this could be like an insert. Now, in this specific case, well, is it true? It's probably not true that they're all going to be the balls, because we're going to have the balls, the pins, and like the walls and whatever like the floor salinity things is, and then like the top. Okay, so we're going to have a bunch of different stuff. Let's have this just be insert ball then. So what do we need in here? Then we can call in from that other function and pass in whatever is needed. So in this case, we're going to create a new dynamic. Oh, I was kind of hoping, stop, wait. Just make it smaller. Is that still readable? Is this still large enough for you? Okay, so we're gonna create a new dynamic. So this can be our ball. It's gonna be equal to a rigid body builder. New dynamic. Awesome, thank you. And then, okay, so we can add additional mass. Right now, I think we're gonna get with just 0 mass. Oh, wait. We do initial mass to make it fall faster? No, because mass doesn't get affected by gravity. Gravity affects everything regardless of the mass at the same rate. Additional principal angular inertia, angular damping, angular velocity. Obviously we can build this. Is there anything else we're gonna add in? Whether or not it's allowed to sleep. And okay, it's position. So we have to care about this. This is going to be an isometry. So to me, that means we need a vector too. So this can be a location, or we'll just call it a position. But that's going to be a vector 2. So an isometry 2. New, and then we're going to pass in the position not the mouse position. This position dot get in algebra, and then I think we also have to give it a rotation. There's that. Is that wrong? New. So, oh, rotation goes in here. Okay, that's what we wanted. Mismatch types, expected destruct, in algebra, isometry. Oh, is it not isometry 2? Is it just isometry? Okay, hold on. This is definitely, okay, this definitely is an isometry 2. So hold on, isometry 2. We want to import you from just N algebra itself. Oh, you take ownership of this. So we need something like a 2N algebra. But it's going to return an N algebra vector 2 F32. So I think data. I think it implements clone, which in that case, that's all we need to do there. And so then here, nope, wrong one. Here, we can just do a 2N algebra, and that gives us it gives us a clone of the data inside. Okay, so we have position now. What else do we care about? User data. We're going to care about user data. Right. Okay, this is a U128 as opposed to a U size. So who do we want in charge of this? We could have physics in charge of this one. Maybe that makes the most sense. So this could be like last used index. Last used ID. It's a U128. Last used ID is, I guess we'll just start with 0. And then here, let's Okay, so our ID is going to be equal to self.lastUseID plus 1. Our user ID is going to be this ID. So we are going to have to return a U128, which is going to be the ID. And so at the very end, we're going to return ID, but not before self.lastUseID is equal to ID.
All right, let's bring that beat back.
Okay, is there anything else we care about? No. Okay, that was pretty much the end. So we have our ball here. Then we can insert the ball into the bodies. So self.bodies, insert, we give it the ball. This gives us a rigid body handle. Then we can create a collider for this. Okay, so build that. What else do we care about? Don't need that. Collision groups. Oh, new. Okay, hold on. It's not gonna be just new, normal new. Ball, we're creating a ball, and then we need the radius. So in here, the radius, which is gonna be an F32. Okay, so now that we're actually making this as just like a circle collider. Don't need to put it into collision group. Don't think I need to care about the delta. Right now, I don't think I need to care about the density or the friction. It's definitely not a sensor. Restitution. We're gonna want to give this a restitution, but I don't know what that is gonna be. So we have our restitution here, which I think is an F32. Is that right, or is it an F64? Oh, it's just a real number, whatever we want it to be. And then, okay, same thing here. User data, and that's going to be our ID. Then I think, yeah, we're done. So then we build that up. We now have our collider. So I don't think we need the collider handle when we insert that. We do need that body handle though. So then we do self.colliders.insert. Okay, so the collider itself. The parent handle is the body handle. Bodies is a mutable reference to self.bodies. And that's it. Now it does give us a collider handle. We don't really care about that because I'm not using it. So now you should be in the system if we call this. That being said, we have a position and a radius. The position we can figure out probably is going to be randomized up above the screen. The radius and restitution, though, we need to add these into our config. Let's put our config over here. There, we'll have our config stuff to the right. All right, so we have the radius of like each of the balls. So we can call this like a choice radius. Let's make those 10 each. And then we're also going to have a restitution, so bounciness is what I'm going to call that. And this is going to be 1, I think is the most. We can go with 1 right now and then easily change that, obviously, to sort of play around with it. So radius, you are at F32. Okay, so then we're gonna head back over to the main library and we're gonna now insert these in. So let's do a self.physics.insert ball. Okay, and then these are the things that we need to grab out of here. So we have our position, our radius, and our restitution. So for the position, we're gonna want to create it randomly somewhere in the screen, like probably above the window. This needs to be a vector too, but that's fine. We have our own vector too. Do I want our random do I want our radius to have like a vector 2 to be able to implement like a random? That could be interesting. Either that, well, regardless, we need to pull in random. So let's go ahead and get that going. So we need rand. So with this is gonna be a new vector 2. It's gonna be ours. There we go. Okay, vector 2 new. Our x and the y. So the x, this is the one that's gonna be random here. For you to be random, we want. We can just store away RNG, then we can do a gen range of the entire width. So let's do that. Then here, do a self.rng gen range. Our range is going to be between 0.0 and self.config.width. As you can see, okay, width is that 1280. The y, now we want this, so let's do we have our choice radius here. So that radius equals self dot config dot choice radius. This is just going to be negative radius. Okay, so we have a position, we have a radius, and restitution. Restitution is going to be just the self.config.bounciness. And that's it. That should insert the balls for us. Now, I really like that I'm not giving this. Oh, that's kind of funny. I'm not giving this a random, like not using the choice at all. Well, we're gonna get the color later. And when we do this insert, we are gonna get the ID out of here. And that will allow us to start storing away some of these things here. Okay, so given that, I would just want to make sure this runs still. Okay, it does. Now, those balls should be dropping, but we have no way to tell because we're not drawing them out. So in our draw, we're going to want to create our, we're going to want to create the mesh and then just display it out. That being said, kind of do need to know where they are, know how big they are. Well, we know how big they are because that's just choice radius. So I might be able to get away with, so in physics, might need to expose something here. The bodies, we need to expose our bodies, which is this rigid body set that has there's an iterator on it, I think. So if I make you public, and we do for body in self dot physics dot bodies dot iter active dynamic. That's actually something really nice because the only things that are active and dynamic are gonna be these balls. That gives us the rigid body handle, which we don't really care about here. So we have the handle and we have the body itself. Okay. We want the so we start creating a new mesh, and then inside of here, we want to start drawing them out. So what is that going to look like? I'm going to do a mesh builder, a circle. Did we pull you in? No. Okay, the point, the location of where this is. I don't know if this is gonna work with it. Let's try. Can I do body dot? So we have position. Oh wow, predict position using velocity and forces. Oh, that's so nice. Okay, so position, that should get it, right? Oh, but it gives me this isometry reel, which is not what I want here, because you're gonna yell at me. Radius, this is gonna be self.config dot choice radius, tolerance 0.1 to make it an actual circle. Color, I'm just gonna make these white for, well, we can make them black, but we're gonna change the color based upon what we actually want later. Yeah, okay, so it can't convert into a mint point from this. So can I do body that? Let's actually just get this out here. I guess we could extract it first. Body dot position. Then in here, I want a position dot x. Oh, only, okay, right. I think there's a better way to get this. It was something like world position. World com. Oh, and that was a point. Okay, so then if I just give you here, are you happy? Oh, you are happy. Okay. Wait, no, you're not happy. Okay, so it is a point F32 2, but it doesn't know how to convert between that. So we do have to do this entire fun thing where it's position dot x position dot y. All right, so that makes that happy, and then down here we'll do a mesh equals builder dot build. No, not that type of mesh builder. Then we can do a graphics draw. So if I just do this, I think it's going to draw out the balls exactly where they are, or not. Trying to build the mesh with less than 3 vertices. Let's see. So we run setup. We're creating the choice balls, which inserts them in here. Oh, we're not doing any kind of like update. So they're in the world, but we need to like actually step. Because like the pipeline needs to be like used for this to happen. Okay, that's good to know. Okay, so step, we're gonna have gravity. That's a reference to gravity. So reference to self dot gravity. Integration parameters is a reference to self dot integration parameters. Yeah, those are just references. Then broad phase is a mutable reference to self dot broad phase. Narrow phase is the same thing. Bodies is mutable. Same thing for colliders. And joints. And you too. Now this hooks. And event handler. We don't know what you are yet. Mainly because I haven't got that far in the tutorials. So you're just nothing essentially. So we have hooks and event handlers. Okay, what are you upset about? Mismatch types. You need to be, oh, right, because it's not going to be this. It's going to be a dot get an algebra. Okay, so then in our main library, in update, do self dot zix dot update. Now does it work? It does, and there's the balls that were randomly created and falling down. Okay, so that's good. Let's see. What else do I want to like add in here? Probably clean up a bunch of this stuff. We also actually don't need if we, oh, you know what? That color, the colors, we want to store those away. So in here, let's have colors. You're gonna be a hash map. Of U128, and this is gonna be a color. Now, is that appropriate? Because, well, no, I think it's gonna be best for just like a quick lookup, and this will make it so we don't have to convert between U128 and usize all the time. So colors, a hash map, new. When we create the choice balls, we get this ID here. Choice gives us a color inside of it, which is perfect. So we're gonna do a self dot colors. We're gonna insert. We have our ID on the left, and the value is gonna be the choice dot color. You need to be public. There you go. Now we have you as a color, and that's it. So that gets inserted there. In here, when we're getting our rigid body out, we can get the ID out too. So let ID equals body dot user data, which means we can then get the color out here too. So color equals self dot colors get, and then pass in a reference to this ID. Everything should have one because we have a default, so I feel comfortable just unwrapping this. And then our color here becomes this color. Oh, you need to be dereferenced so that we just clone it. And let's now see if we have like the appropriate colors, and we should be able to update these colors. Oh, there we go. We have like the pinkish, tannish, and white. And if we come over here, we see, oh, wait, this isn't choices. We want, no, not that one. This one. Here's our choices. Our first choice has a color. The second one does not, so it defaulted to white. So if I change this to something like 15, then one of the colors should be a little bit darker. There we go. And here's this other one. So now we can set what these are going to be. Something else I was thinking would be really nice and kind of cool is we could have a function, maybe up here for like new. A function like new, do we want something like new random? If I do new random, and then I can have like a range for the X and the Y. Could be interesting. So X would be, this would be the X range. I guess it could be just this range like that. Oh, range of an F32, and then a Y range. $32. We're going to return a self here. So in this case, we could generate a RNG here. Oh, data. You're right. We need to do this entire. Oh, because like oh. Wait, hold on. This is easier. We can do a self new, and then for each of these, it's going to be this rnd.gen range, the x range. Like that. So new random, come back to here. So you don't have to do random at all. We don't actually have to store RNG here anymore, so I'm not going to do that. So this position is now going to be a vector 2 new random, and then we give it the ranges that we care about. So we're going to be 0, 0 to self dot config dot width, and then the x is going to be negative. I don't know. Let's like do 5 times the radius. I don't know how I want to do this. Self dot config dot choice radius. Oh, I wonder if I should just. I think I just want to do this like. I don't know if I want like a magic number in there though. It'd be so cool if I could create like a range inside of here, but I really doubt it'd be able to figure that out. We could create our own helper, which would be able to do that. We could also just have. We could have our start min start y. Oh, okay, that's what we could do. We could have a choice start min. You're gonna be 0.0 trace start max. You're gonna be this 1280. They happen to be the same right now, but this will allow me, like, once I get walls going, then they could be, I could separate it out and like maybe make it a little bit different. This is also the X. So I want to duplicate you. So that we have these being the Y. Y min, Y max. So actually, the max is going to be the negative choice radius. So negative 10. So then here we can just say, I want you to be like negative 50. So it's starting somewhere like above each other. So they're randomly positioned above the screen. Which means we need to add you in here. So we have, these are config. So choice start X min 32. You are max. You are Y min. Y max. And then, oh, you're exactly the same. You're max 2. You're Y. Okay, then back over here to our main library. When we're setting up this range, so new random, the X range is going to be this self dot config dot choice start X min through config dot choice start x max. Okay, that should actually give us it's a little bit nicer of an interface for like creating the random location for this. What are you upset at? Missing field choice start x min. Is that in here? Oh, kind of need to save the need to save the entire document if I want. That kind of felt like they were in the same Y. Let's make this a little bit bigger of a difference. Negative like 500, let's say. There we go. Now they're in a now they're very separate. So it was working. It was just very hard to see. So I'm gonna go back to 50. I want some kind of like platform for them to sit on as like things are getting started. Maybe before we do that though, let's clean up some of these. Got 5 warnings. And that's it. No more warnings. Okay. What do I want to do then? We have our choices. We're able to create those. We're able to create as many balls as we want from this. We can create like a script that would just generate these if we want, or I can like manually put them in. They spawn up above the screen and they start getting physics added to them immediately, so they start dropping down. So that's all good. I want them to probably like settle in like a funnel at the top. So what is that going to look like? If we come back to our whiteboard, it's going to look like this. I want most of the screen to be taken up by this part. So just a tiny little bit of like the walls and this down here. So we're going to want to create, I don't think we need to do the walls on the side right this second. Probably just like the platform on the top. So we have this insert ball. We're going to also have a function insert. I guess we can call this a wall. What is a floor but just a wall under your feet? We're gonna have to see what we need. We do know we're gonna get a U128 out of here. Or at least I believe we will. We might as well give it like an ID. So let's start with that. Okay, so we're gonna get our return all set up for us. Now, if we want to create this is gonna be static, not a dynamic. So wall equals, this can be a rigid body builder, static. Obviously, we're gonna have build. We're gonna need a position. So what I'm thinking of for this is the position is centered to where the wall is. So in this case, the center of the wall is just gonna be like, I don't know, down here. I think that's how it's gonna work. And then the collider is gonna be sort of all around it like that. So we are gonna need a position. What do you need in here? Okay, so it's an isometry real. So we have a position, which is this vector 2. And no angle. So allows us to just put the position in here. All right. What's next? Then user data and then the ID. Okay, so that's pretty simple for that. Then we're going to insert this rigid body inside. All right, so what are you? There's cuboid. That's what we want. So then we have the half X and the half Y. So we need to know what the size of this is. Like the width. F32, and then a height should be an F32. So then you're going to be the width divided by 2, and then the height divided by 2. Okay. Let's see. Build, okay. I don't think the walls need restitution. I think that the balls bouncing off of them should be enough. Then we'll have our user data, which is the ID. And I think that was the end. So then we'll insert this in. So we have our collider, the handle, reference to self.bodies, and I think that's it. So then we can go back to the library. We can insert the wall. So self dot insert maybe like floor. All right, and then we have to then do the entire self dot physics dot insert wall. Give it like the position of where this is going, the width and the height of this, which would have to be in here. So what I think I'm gonna do is I'm gonna leave this here for next time. So inserting the floor of the like collector, I guess. Collector. This will be removed. We do need that ID so we can remove it eventually. This will be removed when the simulation starts. All right, and then let's see, what warnings do we have? Just that we're never using this so far, so that's not a problem. We kind of know and understand that. So I think we're good to go here. I'm gonna go ahead and yeah, I'm gonna go ahead and end the YouTube video here. So thank you so much for watching, and I'll see you in the next video.